Hello everyone. Today we are going to discuss about binary search. It is a searching technique which is used to search for an item entered by the user in a single dimensional array. So let us see some of the points of binary search. The first one is it works only in a sorted array, that is, the array has to be in ascending or descending order. Binary search is not applicable if the array is in random order. The second point is it is much faster than linear search technique. And the third point is it works on a divide and conquer basis. Let us take an array which consists of 5 elements. In binary search, the array is divided into 2 halves. So if the element or the item to be searched is present in the first half, we discard the second half, and if the item is present in the second half, we discard the first half. Variables to be used in binary search. The first variable is LB or lower bound, which point towards the first index of an array. The second variable is UB or upper bound, which point towards the last index of an array. And the third variable is mid, which point towards the middle index of an array. So let us take an example. The elements are 4, 5, 6, 7, 8 and 9. The lower bound is pointing towards 0, that is the first index. The upper bound is pointing towards 5, that is the last index. And in order to calculate mid, we have a formula, and the formula is LB plus UB whole divided by 2. So in this example, LB is 0 and UB is 5. Divided by 2 gives you 2.5, but we take the answer as 2, since lower bound, upper bound and mid is of integer data type. So we discard 0.5. And the loop that we are going to use in this case or in binary search is a while loop, because we don't know how many times we have to divide the array into halves. And the condition is lower bound is less than equals to upper bound. So until and unless lower bound is less than equals to upper bound, we are going to search for an item in the given array. Three possibilities where item to be searched might be present. First case, when the item is present in the middle index. That is, if the user enters 6, then the item is present in the middle index of an array, and this is the best case of binary search. Second case, when the item is present in the left half of middle index. So that means it is not present in the middle index, it might be present in the left half of the middle index. And the third case is when the item is present in the right half of the middle index. So the item is not present in the middle index, neither in the left half of the middle index, so it might be present in the right half of the middle index. How binary search works. Divide and conquer rule. So let us discuss the previous cases one by one. The first case, if the item is present in the middle index. Let us take an array which consists of 4, 5, 6, 7, 8 and 9, and let's say the user enters 6. That is, if the user wants to search for 6, so in that case the item is 6 and the middle element is also equals to 6. That means the search is successful, which is the best case of binary search as I have mentioned earlier. And the sample code is if item equals to A of mid, we print search is successful. Now let us discuss the second case where the item is smaller than the middle element. For example, if the user enters 4, then 4 is compared with the middle element, which in this case is 6. As you can see, 4 is present in the left half of the middle element, so the second half of the array is discarded. And the new array will look like this, where lower bound is equals to 0, upper bound is equals to 1, and mid is equals to 0. And upper bound is calculated as mid minus 1. Lower bound remains the same. Mid is calculated as lower bound plus upper bound whole divided by 2, which is equals to 0. And the sample code for this case is if item is less than A of mid, we change the value of upper bound equals to mid minus 1. Now let us discuss the third case where the item is greater than the middle element. For example, if the user enters 8, then 8 is compared with the middle element, which is 6, which means that item is greater than the middle element and it is not present in the left half of the middle element. It is present in the right half of the middle element, and the new array looks like this, where lower bound equals to 3, upper bound equals to 5, and mid is equals to 4. Lower bound is calculated as mid plus 1, which is equals to 3. Upper bound remains the same, and the new value of mid is calculated as lower bound plus upper bound whole divided by 2. Lower bound is 3, upper bound is 5, divided by 2 gives you 4. And the sample code is if item is greater than A of mid, lower bound equals to mid plus 1. Please remember that this approach of division is repeated until lower bound is less than equals to upper bound, which is given in the while loop. And in these three cases, all three cases will not be satisfied simultaneously.